Hello everyone, my name is Jerin James. I'm going to present the paper Video Stabilization using Deep Distilled Motion Estimates. Video stabilization involves the process of taking an unstable video like the one shown on the left and producing a stabilized video. In the general outline of the motion estimation based methods, the first step involves estimating the interframe global motion of unstable videos. Next step involves segregating the unstable component of the global motion and retargeting the frames to obtain the stable video. As one can notice, estimating global motion is the most critical step in motion-based video stabilization. There are various parametric and non-parametric methods to estimate global motion with varying degrees of accuracies. In this paper, we introduce a novel technique to adapt any optical flow network to obtain global motion. This network is significantly better in producing accurate global motion and in eventually producing more stable videos. Towards this, we take an off-the-shelf optical flow network as the teacher network. Then we obtain a student network by introducing some modifications to the optical flow network and train it using knowledge distillation. Now let's get into the distillation process. As a first step towards producing smooth global motion, we introduce a set of low-pass filters into the original optical flow network. However, without any further training, this network would simply produce a blurred version of the original optical flow, which is undesirable. Now, as the second step, we train the student network using a robust loss between optical flow and the predicted global motion. In this two-pronged approach, the low-pass filters force the predicted flow to be smooth, and the robust loss ensures that the global motion ignores outliers like moving objects. This is a sample output from the global flow network. One can see that it has learned to produce the smooth background motion by eliminating the moving objects. Once we obtain the interframe global motions, we stabilize the video using a two-stage process. First step involves stabilization of affine coefficients. Here we extract affine coefficients from global motions. This approach is significantly faster and accurate compared to the typical feature point based affine estimation. When it comes to stabilization, oversmoothing can cause loss of field of view. Hence, we devise a novel quadratic programming based technique which can smooth a video subject to a maximum loss of field of view specified by the user. Since affine or homography are significantly limited in their degrees of freedom, affine stabilized videos would be left with residual motion as shown in the video. We correct this by smoothing the DCT coefficients using a scheme similar to bilateral filtering. Now coming to the visual results, the two videos shown on the right are our methods, the affine and the global ones respectively, and the others are the state-of-the-art methods. One can see that our videos have better stability and better spatial quality compared to the other methods. These are another set of results. Here also we can make similar observations. For quantitative evaluation, we use the standard metrics which are used in video stabilization, and our quantitative results can be found in our paper. To summarize, we introduced a novel technique to adapt any optical flow network to estimate global motion. We also introduced a novel quadratic programming based technique to smooth affine parameters. We also showed that we obtained better stability and spatial quality in our results. Thank you.